So just give me a moment. I will share the mains question set. Okay. So these are specifically the questions only from friction and Newton's laws of motion from the common test mains paper that had happened. So we'll just go through these. So let me know if you have any doubts in any of these questions. Okay, so this was from the mains paper. Does anybody have a doubt in the first or second question? Just go through these two and tell me. Okay, second question, Shikhar, you have a doubt, we'll discuss.
So question number one.
And now you have a doubt in the first question as well. Okay. So as you can see in the first one, okay, Ranak also has a doubt in the first one. So in the first one, the blocks are in equilibrium. So if the blocks are in equilibrium, then here, okay, the tension is equal to 5G. So now you look at this one's free body diagram. There is tension equal to 5G like this. Okay, there is mg sine theta acting in this direction. So that is becoming how much? 10G into 3 by 5. So that is 6G. Okay. So the difference of the two, which one is balancing? Friction is balancing. So you can see here there will be static friction acting in this direction. Okay. And that static friction will become equal to how much? That static friction should be equal to 10G sine 37 minus this tension. So this should be 6G minus 5G. So it should be G or 10 newtons. And in which direction? Up the inclined plane. As you can see, the maximum friction available to you will be more than that because coefficient of friction is 0.5 and normal reaction you can work out. Okay. So is this clear? Anay and Ranak? Okay. Anay, is it clear to you, beta? Okay. Let's move on to the second question. So second question, you have to work out the velocity of this block given the other one has a velocity 10 meters per second. Okay. Block B is moving down with a velocity of 10 meters per second. Block A will be moving in this direction with some velocity we have to find out. So in this we will use the virtual power method. Okay. So what is happening is you can see that on block B, okay, there is 2T acting upwards. It has a downward velocity of 10 meters per second. Whereas on block A, you can see there is T acting like this. So when you look at block A, the tension is acting like this. Okay. Whereas the velocity of the block is in this direction. So this angle is 37 degrees. Okay. So the power delivered by tension on B is how much? Minus 2T into VB. The power delivered on E is TVA cos 37 degrees, and this should be 0. So VA should become 2 VB divided by cos 37. So that is 2 into 10 divided by cos 37, you know, is 4 by 5. Okay, so see that VA will become, how much will become, 25. B is the correct answer. Okay, so Shikhar, this is clear, I hope. Okay, let's move on to the next couple of questions. Third question, anyone has a doubt? Okay, so in third question, see what is happening is that this one has an acceleration. So if you make the 2 kg blocks FBD, you have 10 Newton force from this side, but its acceleration is only 2 meters per second square. That means there is spring force from this side. There is tension in the spring, or Kx, which is equal to how much? You can find that out. So F minus Kx should be equal to Ma for this. Okay. So 10 minus that unknown Kx should be equal to 2 into 2. So that spring force is how much? It is 6 newtons. So now you see the 3 kg block. On this Kx will be acting like this. So this will have an acceleration, say something else, A prime. So the 3 kg block, it has spring force of 6 newtons and some unknown acceleration A prime. So you can find out that unknown acceleration. Okay. So Kx will become equal to, say this. So A prime will become 2. Okay, so hope this is clear. Samarth, the question clear? Okay. Let's move on to fourth and fifth. Yeah, so in fourth, you have to just analyze the normal reaction between all the blocks. So you can see that mass of A is equal to mass of B. So for example, in this system, you can first make a combined FBD and find out the acceleration. So the acceleration will become how much? It will become the force you have applied, which is 30 newtons, divided by total mass. So that is 15 meters per second square. Okay. Then you make the free body diagram of B. So on B, you can see the contact force between them will be acting like this. On E, it will be acting like this. So this N is providing this acceleration. So N will be equal to 1 kg into 15 meters per second square. So N is equal to 15 newtons. That is in this part. Okay. Now in this, it's very easy. You just make A's free body diagram. So there is 2 newtons like this. There is mg equal to 10 newtons like this. So the normal reaction acting on it has to be equal to 10 plus 2. So in this case, the normal reaction is 12. Okay. Similarly, in this case, you make the free body diagram of A in the non-inertial frame. Okay. So there is pseudo force, there is weight, and there is normal reaction. So again, normal reaction is, so 1 kg into 2 plus 10, so 12 newton. So here also normal reaction is 12 newton, this case also. And similarly here also you make the FBD. Okay. So on E, you can see that normal reaction is pushing like this. and it has an acceleration of 10 meters per second square. So normal reaction will become 1 kg into 10 meters per second square. So that is 10 newtons. Okay. So the maximum is in the first case, 15 newtons. Is it clear, Shikhar? Okay. Don't worry, Samat. I'll be sharing the recording with you so you can go through the solution again in the recording. I have to move a little fast because we have to complete all the questions. Okay, anybody has a doubt in the fifth question? Okay, good. So fifth was pretty standard. Even sixth was pretty standard, I think. So anybody has a doubt in the sixth question? Okay, good. What about seventh one? Which one, Ranak? Seventh. Okay. So in seventh one, see what is happening is that you have to find out what is the minimum acceleration you have to give capital M so that small m sticks to it. No? So you are giving this whole system common acceleration E so that this is at rest. There is no slipping. Okay. So what you do is you get onto the frame of this one. So in your frame, this block should be at rest. Okay. So that means if you make the free body diagram in the non-inertial frame for the smaller block, it should be at rest. So what are the forces which are acting in this frame? There is pseudo force that creates normal reaction. Mg is trying to make it slip, but static friction is preventing it from slipping. So static friction has to balance the weight. Normal reaction is provided by pseudo force, and the limiting condition is that static friction cannot exceed n. So mg should be less than equal to mu me. So the acceleration should be greater than equal to g by mu. Okay. So the minimum acceleration that you need to give, a minimum, is g by mu. So Soham and Ranak, is it clear? Okay. What about eighth question? Anybody has a doubt? Okay. Anay, you have a doubt or something? Okay. So in eighth question, yeah, got it. So in eighth question, you just make the free body diagram of the block. Okay. So you have this force acting on it. Okay. You will have normal reaction that the wall is applying. You'll have weight. Okay. And now you have to understand the direction of friction from the tendency of slipping. So you can see the weight of the block is only 10 newtons. Okay. Whereas this force is a lot more. It is 75 newtons acting at an angle of 37. So when you break it into components, you can see that this will exceed this. So your friction will be acting like this over here. Okay, now we have to see whether we have enough friction or not. So for that, break this F into components. So on breaking into components, this component of F will become how much? 75 sine 37. So sine 37 will give you 3 by 5. So 15 3s are 45. Whereas this X component of the force will be cos 37. So 4 by 5. So it will be 60 newtons. Okay. And your mg is 10 newtons, and normal reaction will become how much? It will become equal to 60 newtons. Okay. So what is the maximum friction available to us? It is equal to 0.25 into 60. So it is only 15 newtons. Okay. And what is the balancing force you require here? Fy is more than mg by 35 newtons. So this will become kinetic friction, and this will slip up the inclined plane. So this will be slipping like this. Okay. And what will happen is that y component of force minus kinetic friction minus mg will equal to ma. So 45 minus 15 minus 10 be equal to mass, which is, this will give us the acceleration. So how much is the acceleration? 45 minus 25. So that's 20. So the acceleration will come out to be 20. Okay. Okay. Sujal, Sujal, is it clear? Okay. Okay. Now very quickly go through the vectors questions. Ninth and 10th. If you have a doubt, then we'll come to the integer answer type questions. Okay, let's come to integer answer type questions. Yeah, fine, Dhruv. So let's discuss the first one. So what is happening here is that initially this block is in equilibrium. So initially the block is in equilibrium means that there is some tension here, some spring force Kx, and there is weight mg. Okay, so you can calculate all these forces. So you can use Lami's theorem or whatever. So you can see that Kx by sine 90 is equal to mg by sine 180 minus 37. So is equal to t upon sine 180 minus 53. So that is 27. So Kx is equal to 5 by 3 mg is equal to 5 by 4 T. So you have this. Okay. So from this you can see that Kx is equal to 5 by 3 mg. But more importantly, this tension is equal to 4 by 3 mg. Okay. And in general, you can understand that the vector sum of tension plus Kx plus mg is equal to 0. Now, the moment you burn this thread here, what happens is that at that particular instant, this Kx remains the same as it was over here at the same angle, and mg remains the same, but that tension suddenly becomes 0. Okay. So now there is a net force acting on it, which is the vector sum of these two. This kind of a net force is acting on it. So this net force should become equal to mass into acceleration. So this net force is the vector sum of kx plus mg, and that is equal to mass into acceleration. And we have to find the magnitude of the acceleration. So if if you compare this equation now with this equation, you can see that kx plus mg, which is our mass into acceleration, is actually minus of this t. Okay, so this is nothing but magnitude of this tension. So magnitude of this tension here you found out it is this much. So ma is equal to 4 by 3 mg. So the magnitude of the acceleration is 4 by 3g. So that way you don't have to again do the vector sum of these two. Otherwise you have to do the vector sum and calculate the acceleration. That also you can do, but it will just take you more time. So here n's value should be equal to 4. Okay, so Dhruv, is this clear? Okay. Yes, you can also do that, Samarth. You can break the spring force into components, or you can also use this thing. No? You can also use triangle law. So you saw that this kx was equal to 5 by 3 mg, and this is mg, and you can see the angle between them. This theta is 127 degrees. So you can also use this thing. Now vector sum root of this thing plus this thing square. That you can do that also. Okay. But as I said, that both these methods will be more lengthy. Much easier is that you already know the vector sum of these two has the magnitude of what tension was in the previous part. So just make use of that. Okay. Second question I think is very easy. So doubt anybody will have doubt in that. Okay. Okay. So let us move on to the advanced paper now. Just give me a minute. I'll share that. All right. So let's go through this now. So anybody has a doubt in the first question? Okay, Shikhar, we'll discuss. So let's go through this. So here you can see that whatever force P you're applying, that becomes equal to the tension in the thread. Okay. So when you make the free body diagram of the block, remember the pulley is attached to it as part of the block. So the forces acting on this are this tension along the inclined plane and this tension at theta. And apart from that, there is mg cos theta, mg sin theta, sorry, normal reaction, mg sin theta, and we have to just about apply enough force so that it starts moving up the inclined plane. So here we will keep this as kinetic friction, and the acceleration is just about tending to zero. So next step, you can resolve the forces, and so along this direction your net tension will become T plus T cos theta. Along this direction it will be T sin theta. Then you have normal reaction, and then you have the components of weight, mg cos theta, mg sin theta, and you have kinetic friction equal to mu n, and the acceleration is tending to zero. So acceleration is tending to zero means along this axis, your x-axis, the forces are just about balancing. So T into 1 plus cos theta is becoming equal to mg sin theta. Oh, it's frictionless. Sorry, my mistake. It's a frictionless surface, so that makes life much easier. So there is, so then though you don't have to consider so much. It's a much easier question. So you just have to calculate this now, this condition. So T is equal to mg sin theta upon 1 plus cos theta. Now see, none of the options are directly matching, which means that you have to reduce this. Okay, so this is where your trigonometry comes in. So sin theta upon 1 plus cos theta, इसको हम कैसे reduce करेंगे? We will write this as 2 sin theta by 2 cos theta by 2 upon 2 cos square theta by 2. So this will become tan theta by 2. So ultimately this becomes mg tan theta by 2. So here we are using the formula cos theta is 2 cos square theta by 2 minus 1. Therefore 1 plus cos theta is 2 cos square theta by 2. This formula we are using. So hope this is clear, Shikhar. Okay. So often in a question like this, it can happen that you have made the free body diagram and everything correctly, but just the trigonometry step you missed out. So you have to be a little careful about these things. Yeah. Anybody has a doubt in the second or third question? Okay, so let's look at yeah, Shikhar. Okay. All right. So Yojit and Ranak, let's look at the third question. The third question, let me just zoom a bit into this. Okay, Deva shall come back to the second question. So the third question, let us look at this particular point first. Okay, so if the tension in this thread is T1, then the tension in this thread will also have to be T1 only. How I know that? I know that from symmetry, because you see, if you look at this point A, these two tensions are acting at symmetrical angle. So they have to be equal, because they are 45 and 45. So their magnitudes have to be equal. And small mg acting downwards. So you can see 2t1 sine 45, so 1 by root 2 is equal to small mg. That is giving us t1 is equal to small mg by root 2. Now next we will look at the free body diagram of this point, say B, and there is this tension, let's say T2 acting on it. So for that point B, there is this unknown tension acting at this angle theta here, whereas this same tension T1 which we just calculated is acting at 45 degrees like this. And of course the weight of this capital Mg is acting like this. So now it is about balancing the forces. Now see, since it is asking about theta now, so it is better that we resolve and do rather than use Lami's theorem. So you resolve this, okay. So on resolving, you can see that you will get these equations, that T2 cos theta, that is this horizontal component of this one, that has to balance T1 into 1 by root. Okay, so you can see this is small mg by 2, and this component T2 sine theta has to balance the sum of capital Mg plus T1 by 2 again. So capital M plus small m by 2 G. So now you take the ratio of these two. So you can see that tan theta will become this divided by this. So capital M plus small m by 2 divided by small m by 2. So that is your tan theta. Okay, so Yojit and Ranak, is the third one clear? Okay, so let's move on back to the second question. Yeah, so second question is again about free body diagram. It's saying 5 kg rope moving vertically in the vertical position, okay, with an upward force of 100 newtons acting on it at the upper end. So let's say this is your rope. You have applied some force F of 100 newtons on it. So it's moving up with some acceleration. You can see the weight is how much? 5 kgs, so 50 newtons. So you can find out the acceleration. Going up with 10 meters per second square, because m is equal to 5. Okay. Oh, sorry. There's also downward force. My mistake. So we have to change this. There is also a downward force acting on it. So there is a 100 kg Newton force at the upper end, and there's also this F prime, so 70 Newton. So its upward acceleration is different. It is going to be 100 minus mg minus 70. Okay, so it's going to have a downward acceleration. So this downward acceleration is f prime plus mg minus f divided by m. So 70 plus 50, 120 minus 100, so 20 divided by 5. So 4 meters per second squared downwards. Okay. Now we have to find the tension at the midpoint of the rope. So if this is the midpoint of the rope and this is the top point and this is the bottom point, to find the tension at the midpoint, what you do is you make the FBD of either the top half or the lower half. So I am making the FBD of the top half to begin with. So ये अगर AC है ऐसा, so in this you can see you are applying this force of 100 newtons here, but there will be this unknown tension at this point like this, and there will be m by 2g, which is going to be 25 newtons, and it will have this downward acceleration of 4 meters per second square. So Tc plus m by 2g minus f should be equal to m by 2a. So this unknown tension plus 25 newtons minus 100 should be equal to 2.54. So 85 newtons. You can also get the same thing by making the free body diagram of the bottom half of this. You can also make the free body diagram of section CB, on which now the forces will be like this: tension acting upwards, this acting downwards, F prime acting downwards. So if you make the equation for this, you will get the same thing, 85 newtons. Okay, so Devansh, hope this is clear. Okay. So heavy chain or heavy rope or whatever, you always find out the variable tension at any point inside or any point within the rope by making the free body diagram of that section. Okay, now let's come to the multiple choice questions. Any doubt in the first or second question? Okay, Raj, you have a doubt in the first question. So see, what is happening here is the first one, the block is heavier than the man. Okay, so let's say the block's mass is m1, the man's mass is m2. So m1 is greater than m2. Okay, Samarth will come to the second one. Okay, okay, and coefficient of friction is same for both of them. So now see, suppose whatever force the man is applying, that becomes the tension in the rope that he's pulling with. So on the block and on the man, there are forces like this. Now suppose the block moves. So this, to understand all these options, you have to assume that suppose the block moves, then T is for the block to move. T has to be greater than mu m1g. So this statement definitely means that T is greater than mu m2g. So that means this person will definitely move now, because m1 is greater than m2. That means if the block moves, the person has to move. So that means this option is correct. The block will not move unless the man also moves. Is this clear? Okay, Viraj, the first statement is clear. Okay. Now the man can move even when the block is stationary. That is true, because see, it can happen because m1 is greater than m2. So condition for the man to move is that t is greater than mu m2g, but it can also happen that t is less than mu m1g. So block is not moving, but the man is moving. This can happen. Again, why? Because m1 is greater than m2. Okay. So that is why statement B is also correct. If both move, which one has the greater acceleration? So if this one has an acceleration a1 and this one has an acceleration a2, a1 you can see will be t minus mu m1g divided by m1. So it is t by m1 minus mu g. a2 will be similarly t by m2 minus mu g when you calculate. So now you can see that m1 is greater than m2. So that means a2 is greater than a1. So if they both of them move, then the acceleration of the man must be greater than the. Yes, Shikhar. It is showing negative marking because all three options are correct now. A, B, C is the correct answer. So you'll get positive marks only if you mark A, B, and C. Any other combination you will get negative marks. Or you leave out the question and you will get 0. Okay, let us move on to the second question. Okay, now see the second question is very option specific. Okay. You have to understand that the moment you apply this force here, if this block or if this thing, this wedge gets an acceleration of A, okay, then in that non-inertial frame, this non-inertial frame, there is pseudo force acting like this, which means that there is normal reaction acting like this. Now there are a whole lot of possibilities. Okay, it could be that MA is greater than MG, so this has a tendency of slipping upwards, in which case friction will be acting downwards on this. Okay, it could also be that Mg is greater than Ma, so the tendency of slipping is downwards. So in that case, static friction will be acting like this. So there's a whole range of A's for which this will happen. But first and foremost, you can see that if this force is zero, there is no acceleration, so there is no normal contact force here. So there will be no friction available. So these blocks will have to accelerate. So the smaller blocks. So this option is correct. Okay. Now for one unique value of f, m and m must remain stationary. No, that is not correct. We can see here that there's a whole range of values for which this will happen, because friction can act either upwards or downwards depending on the tendency for slipping. So option B becomes wrong. Okay. The limiting friction between small m and capital M is independent. No, because see, this limiting friction is mu n, and n is equal to how much? It is ma, and A is equal to how much? It's dependent on f. Okay, so it depends on f. So this is wrong. And there exists a value of f for which friction is zero. Yes, that you can see that if A is equal to G, then there is no tendency for slipping here. So friction will become 0. Is this clear? Samarth, the question is clear, beta? Okay. What about this vectors question, the third one? Okay, I'll explain. So see, Shikhar, here what is happening is saying that they are non-coplanar vectors. Okay. So non-coplanar vector means that, let's say, this option, now you're talking about C option. So non-coplanar implies that A is not in the plane of B and C. Okay. So B cross C क्या है? B cross C is perpendicular to the plane of B and C. Okay. So what is A's relationship with it now? Okay. A will have some component along B cross C. Na? Okay. So dot product cannot be 0. You understood? So that is why the option C is correct. In fact, if you just remember, na, that is the condition for coplanarity. Na? That this should have been 0 if they are coplanar. So if they are non-coplanar, this has to be non-zero. हाँ obviously B cross C is a vector है तो उसका dot product A के साथ नॉन जीरो है ना you are doing this operation ना this so this is a vector which is perpendicular to the plane of B and C so unless A is also in that plane this dot product will not be zero ना okay let's understand this whole question now okay others have also asked so okay so Samaj let's see so what is happening that they are non-coplanar vectors okay so what about this let's understand okay so A cross B cross C so A का क्या relationship है with B cross C? Let's try to understand. Suppose B and C are lying in this plane. Okay, suppose we draw a two-dimensional plane like this, and B and C are lying somewhere in this plane. So then B cross C is along this line. It is perpendicular to this plane. Okay. Now where is A lying in this? It is not in this plane, na? So A is somewhere here. Though it might be perpendicular also, but you can see. So A has some acute angle with B cross C also, and it has some angle with B and C also. Okay. So what is the relationship of A with B cross C? Okay. Now if theta is 0, it can be, na, A can also be in this direction. Then this is 0. And if theta is greater than 0, then it is not 0, like the second case. So it may be a null vector. It may be a non-null vector also. So both of them are correct. Okay, so it's very tricky this one. Whereas this cannot happen. Okay. Because A is definitely not in the plane of B and C. Okay, anybody has a doubt in the passage question? Okay, let's move on to the next thing. Yeah, Viraj, you have a doubt in the passage? Okay, which part, the first or second? Okay, so let's analyze the whole thing. Okay, so what's happening here? See, on the 10 kg block, you are applying force F. So immediately some friction has a tendency to slip like this. So this friction's maximum possible value is how much? It is 10 g into zero point 0.1. So it is 10 newtons. And then you look at the lower block, which is the 5 kg block. उस पे ये फ्रिक्शन ऐसा एक्ट करेगा, ग्राउंड पे ऐसा फ्रिक्शन एक्ट करेगा. नाउ दिस फ्रिक्शन मैक्सिमम वैल्यू इज लॉट मोर ना. It is 0.3 into the combined weight, so 150 into 0.3, so that is 45 newtons. Okay, so from that you can understand that this block will never move. This block's acceleration a2 will always be 0. Okay, no matter how much force you apply here, because f1 cannot exceed 10 and f2 is going up to a maximum of 45. You understand? Whereas for this one to move, E1 will be 0 for F less than equal to 10 newtons, and E1 will be non-zero for F greater than 10 newtons. Okay, okay. So this is wrong. I'll just check the options. So when we apply 15 newtons, what will happen? Both the blocks will not be in equilibrium. The 10 kg block will move with an acceleration of how much? 15 minus 10, 5 divided by 10, zero point 0.5. Yeah, so option B will be correct. This should be option B. So that was your doubt, beta. You got the same answer? Okay. Okay. So I'll make a correction. This should be B instead of C. Hope the concept is clear to everyone. Okay. So let's just check out the second part also. So this should be changed to B. Yeah, we'll change it. Okay. So which of the following is true? The minimum magnitude of F needed to make the blocks move is 45. No, both the blocks cannot move. This is also not correct. This is correct. Oh no, this is also not. If F is greater than 10, upper block will slip forwards. Yes. So this one is correct. Okay, so I'll get this correction incorporated, don't worry. Okay. Let's come to the matrix match question. So anybody has a doubt in any of the parts in this? Okay, so let's do part 4. So in part 4, what is happening? Okay, third and fourth both. Okay, let's start with the third part then. So in third part, see what is happening. The horizontal surface is smooth, but there's coefficient of friction mu between the two of them. Okay, so this surface is smooth, but there is friction between these two blocks. So what will happen in this case is there is nothing to prevent this from moving. So this will have to have an acceleration. Okay, this will have to have some acceleration, this block. But the question is what acceleration this block has. Okay. So A prime might be equal to A if there is sufficient friction to prevent slipping, or A prime might be less than A, but both will be non-zero if slipping occurs. Understood, Prachi? Because see what will the free body diagrams look like? On the block M0, okay, so the moment you are releasing that other block, this tension is acting over here. So जैसे ही यहाँ पे tension act करेगा, there has to be a friction acting here. So there has to be a friction acting here. Okay, so they have to accelerate. Okay, so Prachi, is the third part clear? So M naught remaining in equilibrium is not possible for the third part. Okay, acceleration of block M must be non-zero. That's correct. M naught also must be accelerated. That's also correct. It cannot be in equilibrium. So the third part should go with Q and R. Is it clear, beta? Okay. Now let's come to the fourth part. Okay. So in fourth part, what is happening? The horizontal surface has a coefficient of friction mu, and the coefficient of friction is mu prime between the two. So both the surfaces are rough. So this is also having some coefficient of friction. This is also having some coefficient of friction. So now see, one thing which is possible is that if this tension, if this acceleration is zero, because tension is equal to mg, and here static friction is acting, because this is less than equal to the maximum static friction at the bottom. So then all three will be at rest. Okay, but it's not necessary. Okay, so we can't say this. It might be moving. It's not necessary. Okay, so it may remain in equilibrium. So far this can be happening. Okay, M naught must be accelerated. It cannot remain in equilibrium. This is also wrong. Okay, the acceleration of small m must be non-zero in value. This is also wrong. Okay, so straight away by elimination only you can see that this is what is happening. but we can also see what other possibilities are there. Okay, if there is acceleration in the system, then if on the other hand, if that small mg is greater than the maximum static friction at the floor over here, then what will happen is that again this will happen. This will be moving with a, this will be moving with a, this will be moving with a prime. So they might be equal, or a prime might be less than a. So these are also possible. But for this is a necessary condition. So that is why with this option only this will go. The fourth option, it should be only S. Okay. Viraj, is it clear the fourth part? So the system may be in equilibrium, the system may be accelerated. It may be accelerated such that both these blocks move together, may be accelerated such that there's slipping between m naught and m, capital M. All the possibilities are there. Viraj, is the question clear, beta? The fourth part? Let's check out the options. So you can see that in this one it's matching. I've not checked the first two. So on the basis of that only, okay. So that clears this paper. So that concludes the discussion of the common test part. Now next we will do a discussion of any doubts from the module exercises of friction. So just take a couple of minutes break and go through the friction module. I mean the Newton's laws plus friction module. The exercises are mixed. So any doubts in exercise 1, 2, etc., please drop a message and we'll start discussing that. Okay, so let's go through the doubts from exercise 1. So we will start with question number 43. So I'll just explain the question in the board. Wait. Yeah, so see what's happening in question 43. Okay, so 43 we have this situation to begin with, that we have a pendulum like object which is initially at equilibrium like this, and in the next situation you cut this thread, okay, and then it comes to this position here, and you have to compare the tension in the thread when it's at this position versus this position. Okay, so initially before cutting the thread, when it's at equilibrium, that point of time, let's say this tension is T1, this tension is T2, this angle is theta. So you have T1, T2 and mg, and this angle as theta. So you can see that T1 upon sine 90 is equal to mg upon sine of 90 plus theta. So you have T1 as mg by cos theta. Okay. This is the situation because the acceleration is 0. Now later, when the system reaches, when you cut the thread, the system goes into oscillation. So in oscillation, when it reaches this point, this is in circular motion. Okay. So at this point of time, it does not have zero acceleration, it has tangential acceleration. But because its velocity is zero, it's at the extreme position. So because its velocity is zero, so centripetal acceleration will be zero. So at this point of time, what is happening? Let's say the tension is T1 prime. That should act in such a way that the centripetal component is zero. Okay. So T1 prime balances mg cos theta. Why? Because centripetal acceleration is zero. Whereas mg sin theta provides the tangential acceleration. Okay. So anyway, now you compare this and this. So from this you will get that the ratio of T1 by T1 prime is 1 by cos square theta. Okay, so Shikhar, hope this is clear. Okay, let's move on to 45th question. So I'm doing the common doubts first, and then I'll help you out with the other doubts also which you have. So 45th question is about constraint relation. So first of all, we have this, then this thread is going around another pulley attached to the wall here. Then there's a thread connected to the axle of this pulley, which is going around yet another pulley, this one. And this pulley is connected to another block. This is the situation we have. These blocks are labeled A and B. So mass of A and mass of B are given to us as 16 kg and 10 kg respectively. And there's a coefficient of friction which is equal to 0.5 over here. And we have to take G as 10. So first of all, let's understand the distribution of tension. So if the tension in this thread is T, all the pulleys are massless. We have to consider all pulleys to be massless. So what about the tension in this thread? This tension will become 2T. Like this, okay. So the condition for equilibrium of A, the condition required is that weight should be balanced by 4T. So 160 newtons should be balanced by 4T. So the tension is only 40 newtons. Okay. And on B, we can see the maximum static friction is 0.5 into 100. So 50 newtons of friction is available to us. Okay. So that means equilibrium is very much possible. So what will happen? The system will be in equilibrium with tension T equal to 40 newtons, static friction equal to 40 newtons, and the net tension on this acting equal to 160 newton. Okay, is this clear, Shikhar? Okay. Now next we'll move to 48th question. So 48th question is a bit of a complicated question. Just go through it, all of you. I'll explain to you. So you have done centripetal acceleration in detail, right? Centripetal and tangential acceleration in circular motion. because we'll need to apply those concepts in 48th question. Okay, so let's come to that. So just go through the 48th question, all of you. So you have this inclined plane. So there's a sort of three-dimensional diagram made first. Yeah, we will do. So the three-dimensional picture is something like this. So this inclined plane is at some angle theta with respect to the horizontal. And it's a rough surface which has a coefficient of friction equal to tan theta. Which means that if we take a particle and keep it at rest over here, it will remain at rest. Remember that condition for limiting friction. But here instead what we are doing is we are initially giving the particle a velocity, and we are giving that velocity in the horizontal direction along the surface. Okay, so we are giving it an initial velocity, let's say v naught, like this. So this particle p is given an initial velocity like this. Okay. So now to understand this problem geometrically better, what we'll do is we'll develop a system of coordinates where we'll take this as our x-axis, we'll take this as our y-axis, and therefore our z-axis, we take x cross y, will be coming out of the plane. So z-axis will be like this. So now what we'll do is we'll make a free body diagram of the particle from two different angles. So first we will look at the whole thing sideways. So we will look at it like this, that this is our y-axis and this is our z-axis, and x-axis is going into the plane. So when we make the free body diagram of the particle in this situation, the forces acting on it are mg and normal reaction, but we won't be able to see the friction because friction will act opposite to the velocity. Friction will act like this over here. This is how kinetic friction will act. Okay. So we can see that normal reaction is mg cos theta, and there is a component of mg acting along this direction, which is mg sin theta. So kinetic friction, which is mu n, will become tan theta into mg cos theta. So kinetic friction's magnitude is equal to mg sin theta. So this is something we have to remember, that throughout the motion, the direction of kinetic friction will be, the magnitude of kinetic friction will be mg sin theta. Okay. Now coming back to this, what we'll understand is that in this diagram, kinetic friction, what it's doing, kinetic friction is creating tangential deceleration. Okay. So your tangential acceleration, which is kinetic friction divided by mass, it's minus of dv by dt. It's rate of change of speed. Whereas mg sin theta, it is providing normal acceleration. because it is perpendicular to the velocity. So what it does is it turns the velocity vector. Okay, so that is why the particle goes into a path which is like this, and after some time, let's say it's over here. So this is where it was at t equal to 0. Now this is where it is at t. So now we will look at this diagram more carefully, the new one at time t. So for that, let us draw the top view. So this is the one which will become important for us. So in this diagram, when the particle started out at t equal to 0, somewhere here, okay, its initial velocity was a vector in this direction. So because the velocity vector was in this direction, the kinetic friction will always oppose slipping. So the direction of the kinetic friction was like this, whereas mg sine theta will always be like this. So this was the free body diagram initially. But as the object starts slipping, after some time, let's say it reaches here. So at that point of time, उसका velocity का direction कैसा हो जा रहा है? It's becoming like this. And this v is now less than v naught because kinetic friction is acting. So continuously it is decelerating the body. So the direction of kinetic friction will always be opposite to velocity. So our kinetic friction, this diagram is like this, whereas our mg sine theta will continuously act down the slope. So mg sine theta is like this, okay. And remember our coordinate frame is like this. This is our x-axis and this is our y-axis. So when we are seeing the top view, this is our system of axis. Okay. So in this diagram, let us take some unknown angle. So since theta is already used, let's take this angle as alpha. So alpha is the angle by which the velocity vector has turned. So this is at time t. Now what will happen is the particle will continue turning till at some stage this happens. So the moment this happens, you'll see something very interesting, that your velocity vector and mg sine theta will become collinear. They become in the same direction. So when that happens, your acceleration becomes zero because mg sine theta balances friction. So when the velocity vector becomes along the y-axis, mg sine theta and kinetic friction, because always kinetic friction, which is mu n, is equal to mg sine theta. So at this stage what happens, the acceleration becomes zero. So this becomes a steady uniform velocity. So we will write that as the final velocity at some time capital T. So at t equal to capital T, when this angle alpha has become 90 degrees, v has become constant because acceleration has become zero. Okay. So just make a note of the diagrams up to this stage. We will continue further. anytime there is a component of acceleration which is perpendicular to velocity or a force which is perpendicular to velocity in a two-dimensional motion, the path is curved. Okay, so the diagrams are clear, I hope. Now let's see how we'll solve this thing. So the instantaneous in between time t equal to t, let's analyze the free body diagram of that one, this one. So this free body diagram, let's see how we can analyze it in more detail. So there are a couple of ways we can interpret this. Okay, one is we can interpret this in terms of these axes. This is your tangential axis because the velocity vector is along that direction, and this is your radial axis. So what we can do is we can analyze it in terms of tangential acceleration and radial acceleration. Okay, so you can see here that this angle is alpha, so that means this angle is alpha. So we have mg sine theta sine alpha minus kinetic friction, that is your tangential acceleration, that is providing the tangential acceleration. Okay, so you're saying that the net tangential force is equal to mass into tangential acceleration, and the net radial force is mass into radial acceleration. So mg sine theta into cos alpha will become m into radial acceleration. So remember, radial acceleration turns the velocity vector, whereas tangential acceleration, it is equal to rate of change of speed. Okay, this is the same thing as centripetal acceleration. Okay, so anytime there is a curved path happening, this is what happens. If the velocity vector is in this sort of direction, you have two components of acceleration, the radial acceleration and the tangential acceleration, exactly like this. So that concept here. Okay, so in this equation, one will be more important for us, this one. Okay. So let's analyze what this equation is telling us. So this equation is telling us that mg sine theta into sine alpha minus, now remember, kinetic friction is equal to mg sine theta actually. Okay. So mg sine theta is equal to m into dv by dt, because tangential acceleration is rate of change of speed. So dv by dt is becoming g sine theta into this factor, g sine alpha minus 1, this, where alpha is a variable quantity and that angle alpha is continuously changing. So we do this operation and integrate this from t equal to 0 to the final time, the speed will change from the initial velocity to the final speed. Okay. So we will get this equation where we have v final minus v naught is equal to g sine theta into this integration 0 to t sine alpha minus 1 dt. Okay. But we cannot proceed further because we don't know sine alpha as a function of time. So we'll see some way to eliminate this term, this sine alpha minus 1 integration. We'll have to find some way to eliminate this. Okay, so this is our equation 1 in the final form, in the integrated form. So we want to find out this v final, but the problem is this integration. Okay, so we'll find another way to interpret this free body diagram so that we can eliminate that integration. So just write down up to here. Okay, now as I was saying, we will interpret the same free body diagram, but using a different axis system next, so that we can eliminate that sine alpha term. So we look at the same FBD again, but this time we will interpret it using the x and y coordinate system instead of using the radial and tangential. Here we have resolved the forces in which direction, radial and tangential. But next, what we'll do is, for the same thing, we will resolve using the x and y axis. Okay. So we will use this system. This is our x axis and this is our y axis. Okay. So we'll use this relation that okay. So if you see along the y axis, what is our net force? It is mg sine theta minus kinetic friction sine alpha. So that should be equal to this quantity. Okay. Now remember, of course, kinetic friction itself is equal to mg sine theta. Okay, because okay. Now we know from before that the normal reaction is mg cos theta and mu is tan theta. Therefore, mu n is equal to mg sine theta. So using that, this again becomes mg sine theta minus mg sine theta sine alpha. So see, we are again having that 1 minus sine alpha term. So from this, we are getting that the y component of acceleration is g sine theta into 1 minus sine alpha this time. There it was sine alpha minus 1, here it is 1 minus sine alpha. Okay. Now y component of acceleration is basically what? It is rate of change of y component of velocity. So this is this. Okay. So next step, we can now integrate this term. So dvy is equal to g sine theta into 1 minus sine alpha dt. Now we integrate this. Now you can see that when the motion had started at t equal to 0, the velocity was like this. Okay. So the y component of velocity was how much initially? It was 0 at time t equal to 0. So the motion had started with, you had given the object a push along the x-axis. Okay. Whereas by the time we are coming to the final stage of the motion here, capital T, the final velocity is along the y-axis only, does not have an x component. Okay. So at t equal to capital T, Vy is whatever the final velocity is. So the left hand side becomes V final and the right hand side becomes g sine theta into this integration 1 minus sine alpha dt from 0 to t. Okay. Now you compare this equation with the first one and you will see that we can eliminate this term. So first write this down and then compare this with the first one later, and you will see how we can eliminate this unknown integration term 1 minus sine alpha from 0 to capital T. Okay, so let's bring our first equation alongside and see how we can eliminate the terms. Okay, so if you just add these two equations, you can see the right hand side you can get rid of it. So do equation 1 plus 2. So you have Vf plus Vf minus V naught. Left hand side is added, right hand side becomes 0. So you have, so the final speed, which is the speed after a long enough time, is V naught by 2. Okay. So this is what happens as the body slides along. It started at V naught, it decelerates and keeps turning till the speed becomes along the inclined plane. But by then the speed becomes V naught by 2. And at this stage the acceleration is 0. Up to here it is having acceleration. Okay, it is having both tangential and normal acceleration. It is having a tangential deceleration and a normal acceleration. Okay, but the moment it reaches here, the acceleration becomes 0. So from this point onwards, it's just continuing at a constant speed of v naught by 2. So this is the final speed. Yeah, we just add these two, no? So you take g sine theta common, and when you add the integrations, it just cancels, no? You have integration of 1 minus sine alpha Okay, plus integration of sine alpha minus 1. Okay, so it just cancels now this term because this is minus of this. So this can be written as like this, becomes 0. You can see that equation 1's RHS is negative of equation 2's RHS. So when you add them, it becomes 0. Okay, so this is a very lengthy question because it's actually not a JE level question. It's a Olympiad level question, subjective Olympiad level question. But the reason we are discussing it here is because it connects the concept of kinetic friction, free body diagram, and general curved path, where you have to use the concept of normal and centripetal, normal and tangential acceleration. Okay, so that is the importance of this question for you to understand the interrelation between all these things. All right, next up we will look at question 52. So just go through that question. Okay, so let's look at the diagram of that question first up. So we have a system like this. So blocks A, B, and C. Now all surfaces are smooth except for the contact surface between B and C. This is having coefficient of friction mu. Okay, these two surfaces are smooth. Okay. Yes. Now mass of A is equal to mass of C equal to 2m, whereas mass of B is m. So this is the information given to us. Okay. So system is pushed by a force F. All surfaces are smooth except for the surface between B and C. Friction coefficient between B and C is mu. So find the minimum value of F to prevent B from slipping down. So we have to find what minimum value of force we have to apply from this side. Find minimum force so that B does not slip down. So if B does not slip down, this whole system should have a common acceleration of A. So if it has a common acceleration of A, for the combined free body diagram of A plus B plus C, you can see that this whole object has only one horizontal force. So A will become F upon total mass. So that will become F upon 5m. Now, condition for B is equilibrium. So what you do is you make B's free body diagram in the non-inertial frame of the system. You make the free body diagram of B. So there is pseudo force, there is some kind of normal reaction here N1 and some kind of normal reaction here N2. There is mg and there is static friction. Okay. So static friction has to balance mg and pseudo force plus N2 has to balance N1. Okay. And the limiting condition is that static friction cannot exceed mu N2. So mg should be less than equal to mu into N1 minus ma. So this is the equation we have to solve now. Okay. Now we have to eliminate N1 here. So how we'll eliminate N1? So for N1, you look at the free body diagram of the block A in the ground frame. So in the ground frame, this is what is happening. Okay. Or directly you can look at N2 also. Anyway, it doesn't matter. Okay. So you have F minus N1 is mass of A, which is 2m into A. So N1 is becoming F minus 2ma, and A we had just calculated above was F by 5m. So 1 minus 2 by 5, so it's 3 by 5f. So N1 is this much. Okay. So you substitute this over here. So the condition becomes mg is less than equal to mu into N1, which is 3 by 5f minus ma, which is this much. So mg is less than equal to mu into 3 by 5 minus 1 by 5, so that is 2 by 5 f. So that gives you the condition that f is greater than equal to 5 by 2 mg by mu. This should be your condition. So alternately, actually, you can make this simpler by just taking the free body diagram of of C and directly calculating N1, calculating N2. So this question actually can be solved in a simpler way if you just use this equation, so limiting friction mg be less than equal to mu n2, and for n2 you can just look at the free body diagram of C in the inertial frame. You can simplify matters a bit that way. So n2 is equal to 2ma, so 2m into f by 5m. So n2 is 2 by 5 f. So calculation becomes a little bit simpler now. Mg is less than equal to mu into 2 by 5 f, which directly gives you this result. But anyhow, this is the way of solving the question. So hope this is clear. Okay, people. So tomorrow we will continue ahead with work energy. We will keep a bit of time in the end again for discussion of questions pending from the module. But that will be the last 20 minutes to half an hour. Mainly, we will discuss about work energy tomorrow. And yeah, Shikhar, to answer your question, in different books, the chapter is named differently. So there is work energy theorem, there is work energy, okay, there is work power energy. But as you go through the chapters, you can easily understand. Okay, there is definition of work done, there is definition of conservative force, non-conservative force. Then there's definition of the work kinetic energy theorem. Then finally potential energy. So all these things you'll be able to see when you go through the chapters. Okay, so that's it for today, people. Wish you all the best. Make sure you go through all the questions of the common test once more and understand the solutions we have discussed today.